Hello there. Welcome to the video lectures of engineering mechanics. In this video lecture, we are trying to see the curvilinear motion of when it is going to be using the kinematics. So, when the particle is going to be moving a curved path, we need to analyze what is the velocity and acceleration by using the kinematics. So, jump into the problem here. A car starts from rest. So, car starting from the rest, u is equal to 0. The given data I am writing. On a curved road of 250 meters, that's going to be rho r radius, also we can say that's going to be 250 meter radius, and accelerate at a constant tangential acceleration of 0. So, in this case, tangential acceleration at is equal to 0.6 meter per second square. Now, we need to determine the distance at the same time for which the car will travel before the magnitude of the total acceleration attained, it becomes 0.75. So that I am going to be taking total acceleration A is equal to 0.75 meters per second square. So we need to find out the S value as well as the T value before it reaching to the 0.75 meters per second. So then how we are going to be calculating from this one? So so in this case, he has given the tangential acceleration as well as the total acceleration. We know that there is the relationship between existed between these two. So that I am going to be writing the total acceleration A is equal to the square root of an square plus at square we will have. An means here the normal acceleration and at is going to be your tangential acceleration. So in this case, I know the total acceleration, I know the tangential acceleration, then I can find out this parameter. So from this one I am simplifying. An is equal to a square minus at square, that's going to be square root we are getting, right? And then I am going to be substituting in this case, this is going to be 0.75 whole square minus of at is equal to 0.6 whole square. That's going to be square root. So after the simplification, an is equal to, so that an is equal to the value we are getting 0.45 meters per second. So in this case, I got it, the an is equal to how much? 0.45 meter per second square. So once I got the an, then I want to calculate the velocity of that component. An is equal to, what is the formula? An is equal to v squared by rho. So from this one, the v is equal to, what is the formula here? That's going to be the square root of an into rho we are going to be getting, that is normal acceleration into the radius of the curvature. So once if I am going to be substituting in this equation 0.45 into 250 meters. So then finally, what is the velocity at that point? So that v is equal to, I got it, 10.6 meters per second. Can you see here? So an is equal to 0.4 meters per second and the v is equal to 10.6 meters per second. I got it. Now we need to find out what is the S value and what is the T value. So now we are calculating the distance traveled. So that S we need to be calculated. Then how we are going to be calculating here? So in this case, u is available and v is available and the tangential acceleration also going to be available. So what is the equations we do have that one? That's going to be v square minus u square is equal to 2as. So here a is nothing but your tangential acceleration we need to be calculated. So then u square is equal to 0, already we got it, right? So then v is equal to, so in this case v is available, right? And then we need to find out the s. S is equal to v square into 2 into ap. So what is the v value here? That's going to be 10.6. 10.6 into 10.6 divided by 2 into 80 is equal to, we got it 0.6. So from this one, S is equal to, if you simplify, what is the value of your S? So that I got it around 93.63 meters. I got it. So that's going to be 93.63 meters. I got it. Now I need to find out the T value. So how could you calculate the T value? So we do have that equation. That's going to be to find out the time. That's going to be V is equal to U plus AT formula we do have. Because A here is going to be tangential component, we need to take it. So then U is equal to, because it is starting from the rest. So we got it, then we need to find out the time. The T is equal to V by AT. This is going to be 10.6 divided by 0.6. Then the time taken to travel the distance is equal to 17.68. That's going to be 17.68 meters per hour. So in the seconds we are going to be getting. So this way we are going to be calculating the distance as well as the time. Can you see here in this problem they had given the tangential accelerations and the total accelerations they had given. From this one we have calculated the normal acceleration and then we have calculated the velocity at that particular point. So then on that basis, by using the kinematics equations, we have derived and finally calculated the distance traveled and the time taken to travel this distance we have calculated. I hope you people are able to understand the basics whatever we have discussed over here. So still if you feel any difficulty, please put in the comment section so that I can reach you. So I hope for better understanding, one should have to follow the series of video lectures. On that basis, your knowledge as well as understanding capabilities are going to be improved. So, thank you.